All right, welcome to the Barbarack channel. Today we're going to continue working on our Pico MIDI. Last time we covered expression pedal and how to add expression pedal to our MIDI, how to support external expression pedal, and what we ended up with was this. Okay, so in today's so we covered that was the last time, but before that we covered how to support here our MIDI pedals. So we covered RC500 Boss Looper and Digitech Mami. They have different jacks there. We covered how to support LED and switch. So this is kind of a interesting, from that perspective, how to use various devices on Raspberry Pi Pico. Here, then we used expression pedal by using analog to digital converter. But here now, we're gonna cover how to support external pedals, So this is what I'm going to focus on. This is Digitech FS3X Footswitch. Why that one? Well, that's what I have. There are other pedals around, most notably Boss, has very popular FS5, 6, and 7. And when we finish this should support them as well. I don't have them, but they have a slightly different working than my pedal. So the pedal that I'm dealing with, is very simple. So let me show you that. So this is the schematic of it. It's very simple. 3 switches, 2 diodes. That's it. Of course, I open my pedal, so you don't need to do it yourself. And I always advise against that, opening your pedals, because you lose warranty and all of that. But this is real simple. The switches are normally open, and this is interesting because in some cases, those Boss pedals, they have normally closed switches, and they have different options on them, so you can kind of change polarity or something. But here, this is very simple. Normally open. 3 switches. These 2 are directly connected to tip and ring. Here we have diodes that then switch 3, which is, you have them, there's here mode, down, and up. So up is connected to both ring and tip. Now, the reason why we have this diodes here is, that's the only way to support this, because if this was just connected directly to both of them, this is short-circuited. So whenever you close this one, it closes both, so you can't do it that way. So if we look into how this is connected to the Raspberry Pi Pico, so to Pico, this here is what we have. So we have pull-up, internal pull-up that we can turn on, when we're in read mode, and this is going to be pull-up. When it's open, we will read high value on the input, and when it is pressed, this is going to come to ground, and this is what our Raspberry Pi Pico will read. But this, you can see here, then when you press this button, this is short to ground, so this is ground. So this path here, it's on negative potential, because this is plus 3.3, this is 0, so this one is closed. Likewise, that means it's an open, it acts as an open connection. So we only detect switch 1. If we press this one, the same thing, just other way around. This goes to 0, to ground. This is positive, so this one is disconnected. And that way we can detect both. And then when this third switch is pressed, then, you know, both are active and they are both driven to ground. Now, not to ground, it's 0.7 volts or roughly, but that is detected by Pico as low. Now, having said that, that is assuming that our Pico digital I/O is at 3.3 volts. You can have it at different level. You can have it lower level. So that is a bit, I'm not sure if that would be detected then as low, but you know, you can always try. What you could also do is, and this is handy because the way this I see working is we don't need to change anything here because our sleeve here is connected to ground, and great, this is connected to ground. So the other two GPIOs are going to handle this, you know. So we don't need to change anything in our in our breadboard schematic. Everything stays exactly the same. Now, if we have these pull down resistors and we have this ground here instead of positive, you know, instead of high voltage 3.3 volts, and so we have ground here, we have 3.3 here. This will still work. Now, of course, software needs to handle this, but this will still work, but only buttons 1 and 2 will work. This one won't, because if we have this pull down here, this will be at ground all the time. When we press here, this is going to be 3.3 volts, and the both of them will be disconnected, so that won't work. But again, it will work in a way that 1 and 2 will still work if that's the connection. This is the reason why I'm saying this, is that, you know, we have different configurations of pedals around. So so I wired it up here, and if this is exactly the same as last time. As I said, this jack is, you know, sleeve is grounded, so that's the only real limitation, which is not, in this case, it's not a limitation, it's not a problem. So when we used it as expression pedal in software, we set this up to be, you know, to use analog to digital conversion, but here we're just going to use this as global general purpose I/O. So this is that's going to be great, because then we only have to change this in software. So that's really it. Let's see. Let's bring up the code and see how that works. You know. Let's see. It's here. Okay. I'm connected. Let me just bring up some software here, some code, and see how this works. And the wiring is slightly different from the last time, and the only reason for that is I used the bigger breadboard. So that's really it. It's nothing. So let's go through this real quick. I defined, like, if you remember for previous videos, this is a program change MIDI command. So this is for my looper, for example, this changes memory locations. And this is the easiest to show, you know. Then if I go back, this is pretty much, we did this push button thing before. So for example, when I have red LED here, let me run this in, okay? Okay, so it's in. So my red LED is I supported it like this, right? When you press. So we already have this push button support. So this is it here, you know. I just slightly changed this MIDI command. The reason for this is so it can print this out, so we know what's happening without connecting anything to it. Just kind of to demonstrate something. And now, if I go back to the command here, I have these GPIO 27 and 26 and 27 that are connected. So I'm just setting this here up 26 and 27 as pin 1, pin 2. This is tip and ring. And I just exactly the same command here. The only difference here is this MIDI command. What I do here is just to keep the details on, you know, like, so I can print something out. And before I was using LED to, you know, if it is on, you know, I just toggle it, etc., etc. But like here, I need to keep this, you know, keep state in memory, right? So now I can have 3 buttons with 3 different states, and they will be, you know, I would set command on, which is in case of my button there, it was PC1 and PC2. For my button 1, it's going to be PC22 and 23, and for my button 2, it's going to be 33 and 34. And let me just plug this in and show that this is actually working, okay? And it's going to be very embarrassing if it doesn't work, right? Okay, getting a bit tricky here. So let's see, this is working. Yay, it's working. And I'm not changing LED here because I don't have, I have only one. And I press here, right? And you can see it changes 33, 34. And now when I press third button here, all right, so that shows me that both, it detects them as both buttons being pressed. So this is a bit of one of those things I said, I need to work on that a bit more because that doesn't come out of the box. That functionality doesn't come out of the box with that library. So if you want that, if I want to use that third button, I need to do some coding myself. I'm not going to do that today, but I'll try doing it at some stage. So when I spoke about Boss pedals, they have other options. So they can be, I think they're normally closed, but you have other things like momentary latching operation. You have some polarity. There's a bit. It's not entirely clear what's happening there. I would have to have one of them kind of closely inspected more closely when I get a hand one of those. But if we are talking about we can support normally closed very easily, you know. So how do we do this? Is just here this push button has an option to do, say, for example, I can put sense equals 0. So that would be my normally closed. So this would just means when it's normally closed, it's at low level, and then it will be briefly open, and it will be high level, and then it will be closed again. And I'm just going to run this in to show you just how that works. So in this case, you know, like I didn't change this button, it's fine. But now when I change this, have a look. So I'm just, you see when I press it, nothing happens, but when I depress it, it changes, right? So this is where, you know, like it's normally open, normally closed. Obviously, you know, if you have normally closed button, this is not how this is going to work. I'm just emulating normally close with normally open. So this was very quick. Now you would wonder, okay, we have the same wiring and everything, but like, so what? This is actually, when we come to the finished pedal, I'm guessing we're gonna have some better software than what I'm doing here now. So what you can easily envisage is that we can read some configuration from a file, for example. Let me see if I have this somewhere. Yeah, I have it here. So actually, MicroPython supports out of the box reading of files. So, and we can do this. And this example is for ESP8266, but it doesn't really matter. If you look at Python code, it supports, MicroPython supports, whatever, lots of these operations. So how do you do this? For example, let me get the code. So I have code ready here to read it from file. So I'm going to read from, I'm just going to run this and I'm going to go through code after this. So here I have the code from previous time when I did expression pedal, and you maybe remember from the previous video, or if you haven't seen it, see it, please have a look if you're interested in this. But I'm just gonna run this, and it throws exception here. Okay, so here I'm trying to open config text file. Doesn't really matter what is it. So I'm going to read the first line from it, and I'm going to close the file. Now, obviously, you would want to do this a bit more clever way of doing this, but this is just for demonstration, and then we're going to work on this in more detail. But here, I'm going to create this config txt file. I'm just going to save it. Did it save this? Okay, I expect this to be saved. Oh, I just ran this and it appeared there. So the file is there. When I read the file, this configuration, I read a simple text. If there's nothing in it, I'm not going to configure anything. I'm not going to support button or expression pedal. But if I read button from it, yeah, talking about very advanced configuration, or expression, I'm going to either configure button or expression pedal. Okay, so at the moment there's nothing there. It failed previously because it couldn't find the file, so I'm just going to run it now, and it succeeded. So let me see if I press. You see, it's not supported, right? Okay, it's not supported, but the pedal still works, and you can see that this is working. So when I change this and I say here, for example, button, oh, device is busy, I need to, okay, stop, save. Okay, so I saved it. I'm going to run it again. Okay, it read button from the file. So it should still support this, right? Because that's, we are not configuring this is going to be a part of the pedal, but this external pedal here, it's supported. Yay! Brilliant. So, interestingly, I forgot to bring expression pedal. So I'm just going to stop it. I'm going to do exp, save this, and then I'm going to run this again. And you can immediately see here that it's picking up something from the expression pedal, right? From analog to digital converter. So if I bring it to ground, it should be 0, right? or not. Oh yeah, so you saw it briefly going to 0, and now it's like totally going crazy because it appears as just a piece of wire. So that's that. Does this work? You know, like, I mean, I kind of spoke a lot about this, but now, is this working? So I'm going to create this as a button. I'm going to run this. And what I'm going to do is I'm going to plug in. Oh, how am I going to do this? I'm running out of real estate here. Okay, let me just plug this in. There's this. Oh no, I need to put it here. Okay, so this is open. Let me just plug in and hopefully I didn't mess up anything when I was rewiring this. So this is why I use this PC change. You see there. Let's see if this is working. Oh yeah, so it's 1, 2, 1, 2, and now when she's like, can I get this? 22. All right, there's no 23 for some reason. 33, 34, and this one, who knows what's going to happen? 34. All right. But you see here. Okay, maybe I messed up the command. Oh, duh. I forgot this, right? Okay. I had the same. So I need to remember to fix this. So, okay, so 23, 22, 23. So it's working. There you have it. I suppose this is it for today. One thing I wanted to point out at this stage is that when it comes to connecting external devices directly to your microcontroller, and this is literally going directly to microcontroller, we need to be careful about it because it's dangerous because for your microcontroller, not for you. Most of the time, it's not for you because you don't really know what is going to be connected to it, you know, and you can't control. Now, if you're doing it for yourself, you know, you probably know what you're gonna stick there. But like one of the sure ways to burn your Pico or damage it, you know, is to connect active inputs and drive your inputs, for example, at 5-volt levels or something like that. That will damage your Pico. That will damage these inputs. Passive devices will be just fine. They're, you know, you can connect them directly. This is fine, right? For expression pedal, that was just like a pot, you know, connecting it for this is just switches, nothing special. But what's not immediately apparent, but we saw that the third button is actually connecting these two together, or could connect them together. It's not really, but it could connect them together. This means that, you know, you could end up with this being shorted. Now, this is not normally a problem if it is, you know, if these are configured as inputs, but if they're configured as outputs for these CMOS devices, you know, if you drive one output high and the other low, there is a great chance of damaging your device due to excessive current. You know, Pico does list out maximum output current, and you can control that, but this is misleading because this is maximum output current that will still preserve correct output voltage level. So, you know, like whether it's high or low. So, but in this kind of situations, that doesn't matter really, because then you don't have this limitation, because it's not, currents can go way over that value, and you know, you can damage your Pico. Because we are using this as an input, that's not a big deal. But if you remember last time, I used one of them as output for analog to digital, but I didn't use both for output, so we should be fine. Still, there is this element of putting in active device here and driving it with unsuitable voltage levels. That's possibly something we need to look into at some later stage. But for now, just something to be aware of. This was, you know, hopefully short one. This covers nearly everything we need to complete the pedal hardware. I still need to consider some extra LEDs, because now we have 4 buttons, possibly, you know. So one LED might not be enough. And then we obviously have to cover power supply, because presumably I'm going to use this with 9-volt power supply. So because this is my pedal, it would be odd not to use 9-volt power supply. So we're going to cover that in one of the future videos. And after that, we're going to package it into an enclosure, and from there on, it should be just software. But on you know, on our journey, we also learn about how to code Pico, how to use various devices. Hopefully, this was useful and fun. Okay, until next time.